Hello, my name is Neo Ra, and this is my Lab 4 video report on oscillations. The video's contents are as you see on the screen, starting from introduction, experiment, computer model, discussion, and ending with conclusion. The introduction. The purpose of this lab is to use the spring mass system to observe the energy principle and then compare it to a glow-script computational model. The related concepts and formulas. There is the Newton's second law, which argues that F equals ma, and force is needed to speed up or down an object is proportional to its mass. And there is the energy principle, which when there are no energies going in and out of the system of the energy of the system is constant and it is equal to its kinetic and potential energies added together. And finally, the spring force is F equals minus K, that's the spring constant, times the length of the spring minus the original length of the spring. And there's the L hat, which is the direction. Here's a preview of the experiment. You can see the computational model and the kinetic and potential energies all graphed up, and you can see that in the bottom right corner that the computational model and the actual experiment yielded similar results. Here's the experiment. The system of the experiment was the ball, spring, and earth providing gravity, and there were no surroundings because everything was included in the system. This means that there is no energy going in and out of the system being exchanged by surroundings. Here is a video of the actual experiments that I used for this lab. As you can see, it is a mass on a pendulum that is swinging in XY plane. Here are the initial conditions. The ball's mass was calculated to be 400 grams, the weight mass, and the initial position and velocity of the mass was set as it was in the video. And then there was the time, delta t, going until 5.5 seconds, which is the length of the video, and the spring force and the velocity and position of the ball was modeled using the formulas that I explained in the introduction of the video. Here is the result of the computational model. And here are the results. As you can see, the experiment was successfully modeled in the computational model, and you can see that the total change in total energy, as you can see in the bottom left corner image, the total energy of the system is constant. And as you can see on the images on the right, the comparison of the computational model's x position and y position to the experiment's x position and y position were quite similar. The possible sources of error could be my mistakes in mass points placement in tracker system, and there could be neglected forces like heat exchange and air resistance, and the formulas could have been mistyped. For the questions, for my model system, the energy principle was satisfied because the total energy is constant. No energy is lost or gained in the total system, as you can see from the plots of my energy graphs. And the X oscillation period was 1.614, while Y was 1.519. There was a subtle difference, but that may be of neglected forces like air resistance and etc. Conclusion, we successfully demonstrated the energy principle with spring mass system and successfully represented it with a computational model.